folks, this is Dr. Carter. Today we're going to be talking a bit about faults and mountain building. We are here in beautiful Lakeview, Oregon. California's a couple miles to the south here. You're looking east that way. This is Highway 395 behind us. And so the thing I'm really excited about here, and what you're going to see on the time-lapse video from the road, is some shots of us basically driving along the escarpment of the fault. But what I love about this is, so what you're looking at here is a textbook quality normal fault escarpment. You kind of see there's like a hillside here. Something gets very steep, and there's no river cutting it. There's nothing really that seems like it could be a powerful agent of erosion. And then you look above there, just between us and that L, if you can spot it. And what you see is you go from sort of a flat hillside, a little sort of terrace there, to something a much steeper hillside. I'm going to see if I can get a shot of this without putting myself in the path of traffic here. Yeah. And like most faults, it's not just a single strand. There's usually a couple of faults all sort of taking up some of that strain there. This is awesome. Let's see. Not sure if I'm going to wander in the streets. Good idea here, but yeah. I mean, this is just one of those places where, like, when you know what to look for, it stares at you. So that little bench up there, then the sun steepening, that is textbook normal fault action. You find these in the Wasatch Range of Utah. You find them in along Lake Baikal in Russian Siberia. You find these on the edges of the African Rift Valley. And that's kind of what we are tectonically in, is something a little bit akin to the African Rift Valley. And we're going to see many features as we drive up Highway 395 that look like things, a little bit like things that you might find in the African Rift Valley. Though, in contrast, the Rift Valley, which is kind of spanning the equator in mostly tropical latitudes, we are here in a healthy temperate latitude, and it's probably about, I think we're about 42 degrees north or so here. So we're going to definitely see a bit of different vegetation. What a fun, and the sort of expression of it here is not just a single rift valley, but a series of valleys that we've been driving through on Route 140 for the last hour and a half. Little blocks of tilted crust, and these tilted bits of crust that sort of tilt and extend. All this is powered by an unusually shallow asthenosphere in this region. We're probably seeing something related to some kind of break-off event associated with the Mendocino Triple Junction, several hundred miles to our west, taking place in this larger region. And we're going to see it all the way out to, for probably the next couple days, we're going to see various expressions of this sort of the Great rifting of things. It's I'm still trying to figure it out. It's one of those things, yeah. So, yeah, and so you can kind of see there's some other beautiful mountains to the west. You also notice it's a lot cloudier to our west. This is your textbook rain shadow effect, where most prevailing winds and storms come from the west, and as they're forced up over the mountains, as we've described earlier, the moisture condenses, and you get precipitation and condensation on the windward side, and on the leeward side, as the air descends, its capacity for moisture increases, and so the air is fairly dry out here in this region. We're also at about 3,000, 4,000 feet up, so it's still nice and cool even on this early January or July day, or June day. Days are sure starting to fade here. So, all right, take a look, enjoy the video. We're going on a drive in a moment. Hi, Dr. Carter here. Welcome to Lake Abert in eastern Oregon. We're just about 20 miles north of Lakeview now. Why are we stopped here? Depends which lecture we're looking at. Perhaps if we're in a volcanology lecture, we are seeing a absolutely stunning example of flood basalts. The entire cliff is comprised of lava flows, as is everything above me. This is your flood basalt province. To give you a sense of the scale, this covers a good chunk of the eastern part of Oregon and a good chunk of the eastern part of Washington, and Washington is still over 200 miles away from here, to give you just that kind of sense of scale, how huge these lava flows travel. Now, hopefully you've already got enough igneous rocks teaching to basically recognize that dark-colored igneous rocks are basalt. And yes, you can definitely get large igneous provinces with felsic rocks, but these extensive lava flows traveling tens, even some places hundreds of miles, can only really happen with a very runny lava with basalt. Exactly how this took place is still, let's just say, up for debate. This is actually not the largest of the flood basalt provinces. There's one in Siberia that's much bigger. There's one in southern India that's much bigger. There's a couple other these lips, as we call them, large igneous provinces in the ocean that form massive plateaus. And the ones in the ocean might not form by the same mechanisms that the ones on the continent, so crust form. There's a lot of unknown here. But they are absolutely spectacular. Spectacular to look at, witness, and be a part of. Now, the second feature we see here is a fault. I talked about this in an earlier video about this is the Abert Rim, one of the best exposed normal faults anywhere really in the world. Normal faults tend to create steep slopes, and you can see even on this steep slope there is a bit of mass wasting, but what's stunning is, you can really just see the offset here, such spectacular fashion. There it is, that steep slope dipping at about, dipping at about 45 degrees or something like that. And then if you look across the valley, across this utterly spectacular lake, you can see another tilted slope, indicating that we are in a half graben. So the bedrock on that slope continues below the valley, what we see here as the valley floor, and this has since filled up with sediment eroded from this side and that side of the valley. At points, this lake's been quite a bit bigger during the last ice age. There was a bit more runoff from the glaciers, and this took up quite a bit more space. Space of the shoreline is much higher. I don't see any paleo shorelines here, but I believe they must exist. I think I might see a couple maybe out in the distance there. You can kind of see a little escarpment way off in the distance. That might be the paleo shoreline on the other side there. It's really hard to tell. It's not exactly level. Well, yeah, I see escarpment, so, yeah. And what you see now is a very small, very shallow salt lake, and this is the Endoheric Basin, so all those chemical weathering products are in the water. The water evaporates, and as it evaporates, the chemical weathering products, halite and gypsum are probably the most primary things here, end up crystallizing and precipitating, giving this sort of beautiful white salt flat we have out here during drier spells. And again, you can really see the normal fault. Very few places are normal faults this obvious, but this is like sort of like, you know, you're looking at a normal fault when you look at a feature like this.